It's over. James Webb Space Telescope failed. How will they fix his problems? After more than a decade of delays, the James Webb Space Telescope is finally ready to peer deeper into the universe and farther back in time than any telescope ever has. All that remains is to get the James Webb Telescope into space and securely position it 1 million miles away. However, this seemingly straightforward task is anything but simple, as the James Webb Telescope could potentially be the most challenging creation humans have ever attempted to place in space. With such an ambitious endeavor, the question looms: what if NASA's James Webb Telescope fails? And if it does, how can its problems be rectified 1 million miles away? Welcome to our new video. As we embark on this cosmic journey, be sure to hit that like and subscribe button. Stick around till the end of this video, as I'll delve into how we can address the challenges of the James Webb Telescope if they arise. Let's dive into the intricacies of this grand astronomical undertaking. When constructing an intricate device like the James Webb Telescope, designers meticulously compile a list of components that, if any one were to malfunction, could lead to catastrophic mission failure. Astronauts who have worked on the James Webb project explain that the goal is to minimize this list of single-point failures by incorporating backup systems and redundancies. Nevertheless, due to design limitations and budget constraints, certain elements inevitably remain on this list. For instance, let's reflect on the Galileo probe sent to Jupiter in the 1980s with around 30 single-point failures. Contrastingly, the Mars lander boasts over 100 of these vulnerabilities. However, the James Webb Telescope sets a record with a staggering 340 single-point failures on its list. This long list of potential pitfalls stems from the inherent nature of this ambitious instrument. Indeed, the challenge faced by designers was monumental. The James Webb Telescope needed to be precisely positioned in its orbit at the Earth's L2 Lagrange point, 1 million miles from Earth, compared to the Hubble telescope's orbit at a mere 340 miles. Striking a balance between the requirements of a potent infrared telescope and the constraints of currently available rockets was no small feat. The ingenious solution was to fold the James Webb Telescope into the nose of an Ariane 5 rocket for launch and then deploy it in space, much like a transforming mechanism. However, the most significant hurdle the James Webb Telescope faces doesn't lie solely in the sheer number of single-point failures. It's the intricate interconnections among these failures. The delicate orchestration required for one part to fold out correctly so that subsequent components can follow suit underscores the complexity of the mission. Nevertheless, it's crucial to acknowledge that this intricate design isn't mere guesswork. Engineers and technicians have dedicated years to envisioning potential scenarios, running simulations, and testing each component meticulously. Over 10,000 individuals have contributed to the James Webb mission in various capacities, attesting to the enormity of this collective endeavor. Yet, despite the $10 billion budget and the aspirations of countless astrophysicists, the James Webb team recognizes that they must confront the extensive list of make-or-break moments. The telescope's orbit is another distinctive factor. Unlike the Hubble, which orbits a mere 340 miles from Earth, the James Webb Telescope will tightly orbit the L2 point, situated 930,000 miles away. This position allows the telescope to remain relatively stationary with respect to Earth, leveraging the unique gravitational interplay between the Sun and our planet. The decision to position the telescope at L2, among 5 potential Lagrange points, was influenced by its capacity to shield the telescope from infrared radiation, a form of heat. Once in space, the James Webb Telescope will operate autonomously due to its remote location. This is a stark contrast to the Hubble, which necessitated several servicing missions before its proper functionality was established. The James Webb mission, on the other hand, isn't designed for servicing, given its perilous orbital distance. While NASA states that current servicing capabilities aren't applicable to missions at L2, astronauts remain optimistic, highlighting the inventive nature of space exploration. At the core of the James Webb Telescope's architecture lies its Sunshield, a colossal structure spanning over 3,000 square feet. Comprising 5 thin layers of special thermal material, the Sunshield creates a temperature difference of around 570 degrees Fahrenheit between its warm and cold sides. The unfolding of this Sunshield is a pivotal moment, with its tightly folded material unfurling on either side of the telescope 3 days after launch. Failure to secure these pallets in place accurately could cascade into issues during subsequent deployment stages. Further complications arise due to the unpredictability of thin materials' behavior. The primary mirror, another vital component, will unfurl on day 13. With its gold coating and hexagonal honeycomb structure, this mirror is the largest ever placed in space, boasting a collection area 6 times larger than that of the Hubble telescope. Each of the mirror's 18 hexagonal segments, each 4.3 feet in diameter, is equipped with actuators to precisely focus light. The margin for error is minimal, as even the slightest imperfection could undermine the telescope's ability to capture distant cosmic wonders. Amid the plethora of single-point failures, it's important to recognize that such occurrences are not inherently negative. Single-point failures can affect overall performance and mission success, but meticulous reliability testing and simulation analysis are conducted to instill confidence that these failures won't transpire. While many critical decisions, judgments, and tests have been executed, the James Webb Space Telescope's ultimate success rests on a delicate precipice. In the end, all we can do is await the images that might revolutionize our understanding of the universe and our place within it. Thank you for joining us on this captivating cosmic journey. Don't forget to hit that like button and subscribe for more celestial updates. Stay tuned as we continue to unravel the mysteries of the cosmos.